Hello everyone. So today my topic is projectile motion. So guys, what is projectile motion? See, projectile motion is a kind of vertical free fall in which the body's motion occurs only under the influence of gravity. We all know that what is vertical free fall? Free fall is a kind of motion that occurs solely under the influence of gravity. So projectile motion is a part of free fall only. Okay, so let's discuss the projectile motion in detail. So let's start. All right. First of all, let us write the definition of projectile motion. So what is projectile motion? That is the motion that occurs solely solely under the under the influence of gravity. Okay. So in projectile motion, see, a motion can be separated into two different axes. That is one along the x-axis and one along the y-axis. Okay, so we can write here. It can be split into, it can be split into two different axes. All right, it can be split into two different axes. Okay, so let us understand the projectile motion. Consider an x-axis and y-axis. Like this is my x-axis and this is y-axis. So this is y-axis and this is x-axis. Okay. And a body is projected in this way with some initial velocity u that is making an angle of theta with the horizontal. Okay. Now see, this initial velocity, this initial velocity can be broken into two of its components. One component is along the x-axis, which is ux, and one component along y-axis, which is uy. All right. So see, it has split into two different axes. That is, one is along the x-axis, their initial velocity is ux, and one is along the y-axis. That's initial velocity is uy. All right. So we can write the respective values of ux and uy. So ux will be u cos theta and uy will be u sin theta. Okay. Ux will be u cos theta and uy will be u sin theta. Okay. Now, another point is that we have considered frictionless environment. That is, there is no air friction. So here, air friction, air friction is air friction is ignored. So here air friction is ignored, then the acceleration along the x-axis can be considered as zero because there is no acceleration along the x-axis, no external force along the x-axis. So there is no acceleration along the x-axis, and the acceleration due to gravity is always pointing towards the center of the earth. So acceleration along the y-axis is actually minus g. Why I'm taking minus g? Because we know that the acceleration is pointing downwards and it is pointing towards the negative y-axis. So it should be considered as minus g. All right. So we know the parameters ux, uy, ax, and ay. So first of all, the first thing that we need to find out is that velocity velocity at time t. Okay, velocity at time t. Now I need to find the velocity, final velocity after time t. We know that its final velocity will have two components. One is along the x-axis and one is along the y-axis. So let us write the equation along the y-axis first of all. So Vy will be Uy plus Ayt. Okay. So substitute the values of Uy and Ay. We'll get Vy as Uy, and Uy is U sine theta. Ay is minus G into T. Okay, so this is Vy. All right, this is my velocity y component. Let us write x component now. So Vx equals Ux plus Axt. Now, since there is no acceleration along the x-axis, so this Vx becomes Ux. That means x component will never change in a projectile motion. So therefore, Vx becomes U cos theta. Vx become U cos theta. Okay. So Vy will be U sine theta minus Gt and Vx will be U cos theta. Now guys, suppose I need to find what is the angle made by this final velocity with the horizontal. So let us suppose the angle that it is making with the horizontal is alpha. So we can easily find tan alpha as Vy divided by Vx. Okay, so therefore, tan alpha becomes Vy is u sine theta minus gt divided by u cos theta. All right. I have substituted the value of Vy and Vx. So tan alpha is u sine theta minus gt upon u cos theta. All right. So this is the value of tan alpha. So this is my first point, that velocity at certain time t. Okay. All right. Now my second point is I need to find my second point is time of flight. Okay. So to understand the time of flight concept, let us draw the diagram again. This is y-axis. This is x-axis. And suppose a body is launched at this point, which is u, that makes an angle of theta with the horizontal. Okay, this is my point O. So the body will follow the path like this. Okay, and suppose it strikes at this point A. Okay, so what is time of flight? Time of flight is the time taken by the body to reach from O to A is known as time of flight. Okay, so O and A are at the same level, so it is defined as time taken by the projectile to reach to the same level from where it was launched. Okay, so we can write the definition as time taken to reach to the time taken to reach to the same level from where it was launched. Okay, so this is time of flight. Now I need to find the time taken to reach to the point from O to A. Now see the total displacement. If you need to find the total displacement, then it is along O to A. All right. O is my initial point and A is my Final point. So O to A, this is my final displacement. So as you can see, the final displacement is along the x-axis only. That means its net displacement along the y-axis is 0. Okay, so this delta y is 0. Okay, so apply the second equation of motion along y-axis, that is uyt plus half ay t square. Okay, so 0 equals uy can be written as u sine theta, and small t can be written as capital T, which I need to find. Ay is minus g, and this is t square. Now, guys, if you solve this above equation, you'll get the value of t. First is 0. So definitely 0 can't be my answer, because 0 is there because the body is at the origin at t equals 0. So delta y is also 0 at this point. Another value of t which I'm interested is t is 2u sine theta, 2u sine theta divided by g. Okay, so this is my equation to calculate this time of flight. Okay, so as you can see, the time of flight depends entirely on the vertical component of initial velocity. Okay, so t equals 2u sine theta upon g. All right. Okay, now let us move on to the third parameter that I need to find is the maximum height. The maximum height. Okay. So to understand the concept of maximum height, let us draw the diagram again. Okay. This is my y-axis and this is my x-axis. Okay. Consider a body is projected in this way with u as initial velocity and angle theta. Okay. So if you draw the path taken by the particle, so it is like this only. Now, what is the maximum height? See, maximum height is the distance between the topmost point and the horizontal level. This is this is the maximum height, capital H. Okay, this is my maximum height, capital H. So, first of all, if you draw the velocity vector at the maximum height, the velocity vector will be drawn like this only. Okay, this is the velocity vector at the highest point. Now, guys, as you can see, at the topmost point, the velocity is pointing towards the positive x-axis. That means the net velocity is along the x-axis only. So at the highest point, total velocity is along the x-axis. So its y component is 0. At highest point, y component is 0. All right. So we can apply the third equation of motion along y-axis, that is Vy square equals Uy square plus 2ay delta y. Okay. So Vy can be considered 0 because at the highest point Vy is 0. Uy square is u square sine square theta. Ay is g and delta y is capital H. Delta y is capital H. Okay. So after rearranging this equation, this H comes out to be u square sine square theta upon 2g. Okay. This is the maximum height. So u squared sine square theta upon 2g. As you can see that this maximum height is also depending upon vertical component of initial velocity. Okay. So we can find the relation. We can find the relation between maximum height and time of flight. So maximum height is uy square upon 2g. Time of flight is 2uy upon g. So if you want to cancel uy component, you have to square the time component. That is t square. So the relation that you can get between h and t is h equals gt square. H equals gt square upon 8. Okay. So this is the relation between the maximum height and the time of flight. So h equals gt square upon 8. All right. Okay. Now, my fourth parameter is my fourth parameter is the range. Okay. Now, what is range? Let us draw the diagram again. This is y-axis, x-axis. U is my initial velocity. Theta is the angle. The path taken by the projectile is this one. So it starts from O and it lands on A. So what is range? It is the distance between this point O and A. Means that this net displacement along the x-axis. Okay, so range is the displacement along the x-axis. Okay, so first of all, I need to find this delta x. So this delta x becomes ux. Now, the net displacement along the x-axis is being traveled by the time of flight. So delta x becomes ux into t. So delta x can be written as capital R ux into t. Okay, this is the first form of this range. Okay, another formula to calculate the range is ux, and t can be written as 2 uy upon g. So it can be written as 2 times ux uy upon g. Okay, this is another form of range. And third and foremost form of this range is R equals u square to sine theta cos theta upon g. Now, by trigonometry, we know that 2 sine theta cos theta is sine 2 theta. So another formula to calculate the range is, that is u square sine 2 theta upon g. Okay, so this is the third form of my range. Okay, so if you look at this formula carefully, when theta is 45 degree, when theta is 45 degree, we get the maximum value of sine theta. So at theta equals 45 degree, we get the maximum range as u square upon g. Okay, so I'm sure you must have understood the concept of projectile motion and the various parameters that we have discussed. All right, so thank you so much. Have a nice day. All right.